Yes, I am Raghavan from all Bohrs Educational Institutions. So I welcome you for all Bohrs Chemistry e-learning program. So in this 12th session, so we are going to discuss some important concepts of Bohrs theory. In the earlier session, we had done the complete Bohrs theory, that is postulates of Bohr's atomic model. Okay, so once again today let us revise all the postulates of Bohr's atomic model once again. Bohr's theory. Okay, now in this Bohr's theory, once again let us see the important points of Bohr's atomic model, then we can go to the derivation part. Okay, so the quick revision of this Bohr's theory. So Bohr's atomic model, Niels Bohr explained atomic model based on Rutherford's atomic model and Planck's quantum theory. Rutherford's atomic model, so from Rutherford's atomic model he explained planetary motion of model of atom. That means various planets are revolving around the sun. Similarly, electrons are revolving around the nucleus in the atoms. Okay, so that is a concept he has taken from the Rutherford's model. Okay, and from Planck's quantum theory, according to that, when electron transition takes place between two energy levels, the change in energy delta E is equals to E2 minus E1, that is equals to h nu. Okay, so this is the concept from Planck's quantum theory. So Niels Bohr explained the atomic model based on Rutherford's model and Planck's quantum theory. Okay, now the important postulates of Bohr's theory as follows. Okay, first point is negatively charged electrons are revolving around positively charged nucleus in closed circular path. This closed circular path is called orbit or shell. Orbit or shell. That is the first point we can say. Orbit or shell. Because the Bohr's theory completely, it explains the nature of the orbit only. It does not explain the subshell, orbital or the orientation of the electrons. Okay, so he describes that orbit. Okay, once again, electrons are revolving around the nucleus in closed circular path is called orbit or shell. Okay, second point we can say orbit is denoted by the symbol N. Okay, next the number of orbits. Next point is the number of orbits from the side of nucleus. Number of orbits from the side of nucleus are designated as N is equals to 1, 2, 3, 4 and so on. Or the same orbits can also identified by K, L, M, N, O, P, Q and so on, shells. That is the designation of the various orbits. Okay, next coming to the fourth point is as long as electron is revolving around the nucleus in closed circular orbits, the electron neither lose energy nor gain energy. That means each orbit is associated with a definite fixed amount of energy. Therefore, orbit is also called stationary state. Stationary state or stationary orbit or energy level. Energy level, or we can also call it as principal quantum shell. Principal quantum shell or principal quantum number. Okay, so that is the principal quantum shell. That means stationary orbit. He describes the stationary orbit. Next, coming to the fifth point. Yes, what is that fifth point? That is when electron is revolving in circular orbits around the nucleus, the angular momentum of the electron is quantized. The angular momentum of the electron is quantized. So mvr is equals to, that is, the quantized angular momentum values are equal to integral multiple of h by 2 pi. That means mvr is equals to nh by 2 pi. Okay, so this is about quantization of angular momentum of the electron. Okay, done. Coming to the next point is as the number of orbits increases, as the number of orbits increases, that means n value increases. As the number of orbits increases, that means as n value increases. That means as the number of orbits increases, size increases, energy also increases. Size and energy both increases. Size and energy both increases. Done. Okay, but energy difference between two successive orbits decreases. But energy difference, but delta E, energy difference between successive orbits. Successive orbits means first orbit and second orbit. The energy of first orbit and second, the energy difference between E2 minus E1 is greater than E3 minus E2. It is greater than E4 minus E3. So the energy difference between the two successive energy levels gradually decreases as the n value increases. Okay, this we understand. Now coming to the seventh point as like, now when electron transition takes place between two energy levels, when electron transition takes place between two energy levels, the change in energy delta E, that is equals to E2 minus E1, that is equals to h nu. When electron transition takes place between two energy levels, the change in energy is given by this expression. Okay, so by absorbing photon energy, the electron jumps from lower state to higher state, and when jumps from higher state to lower state, the electron emits photon energy. So these are the few important points of Bohr's theory. Okay, so from this, what is the significance of Bohr's theory? Bohr's theory signifies to explain. He describes orbit. He describes orbit or shell. Okay, so number of orbits, done. As the number of orbits increases, and see another point, orbit is stationary orbit because energy of the orbit, that means energy of the electron in the orbit is constant. Yes. As the number of orbits increases, size and energy both increases. Okay, so these are the important conclusions of Bohr's theory. Okay, now let us see the derivation, how we can derive the size and energy of the Bohr's orbits. Okay, now derivation of the equation to express size of the orbit. Derivation. Okay, derivation to calculate radius equation. To calculate radius equation. So electron, according to Bohr, electron is revolving around the nucleus. According to Bohr, the electron is revolving around the nucleus in closed circular orbits. Electron is revolving around the nucleus in closed circular orbit. Okay, in closed circular orbit. And say this is the nucleus and this is the electron. Nucleus, say it is electron. Okay, the electron is revolving around the nucleus with a radius r. With a radius r. So then the nucleus attracts the electron towards itself. The nucleus attracts the electron towards itself. Okay, the electron is revolving around the nucleus with a radius r. Okay, so the force of attraction towards the nucleus, that is called centripetal force. The force of attraction towards the center, that is called centripetal force, that is minus Ze square by r square. Minus Ze square by r square. That is the force of attraction between the nucleus and electron. The nucleus is attracting the electron with this much of force. Then the same amount of force is acting on the electron to keep away from the nuclear attraction force, that is called centrifugal force. Centripetal force is towards the center and centrifugal force, that is away from the center. Okay, so how much force is acting on the electron? That is minus mv square by r. mv square by r. Okay, the attraction force towards center is centripetal force, that is this, and the same amount of force is acting on the electron to keep away from the nuclear attraction, that is called centrifugal force. Okay, now so we understand the centripetal and centrifugal force. Let us take the centripetal force and centrifugal force. For example, when we are traveling by a bus, okay, and we are all sitting in the bus and the bus is moving with some certain speed and it is taking the left turn. When the bus is turning towards left, so the people sitting in the bus, they move towards right hand side. That means the force is in the direction of the force, that is centripetal, and the force is acting on the object away from the center, that is centrifugal force. Centripetal force is towards center and centrifugal force is away from the center. Okay, since for a stationary orbit, what is the meaning of stationary orbit? So stationary orbit means as long as electron is revolving around the nucleus, it neither loses energy nor gains energy. That means it is not losing energy. That means it is not going closer to the nucleus and it is not gaining energy. If it gains energy, what happens? The electron may excite. Okay, so for a stationary orbit, the centripetal force is equal to centrifugal force, that is Ze square by r square, that is equal to mv square by r. For a stationary orbit, Ze square by r square is equals to mv square by r. The centripetal force is equal to the centrifugal force. This is according to Coulomb's law. Okay, this is according to Coulomb's law. Say it is equation 1. This is according to Coulomb's law. This is according to the Coulomb's law. Fine, very good. Right. Now, angular momentum of the electron revolving in the circular orbit. Angular momentum of the electron. Angular momentum of electron. Angular momentum of electron in circular orbit. In circular orbit is given by the expression, what is that? That is mvr is equals to nh by 2 pi. We know that nh by 2 pi. Take out velocity v is equals to nh by 2 pi mr. This is velocity terms. Okay, squaring on both sides. squaring on both sides. Squaring on both sides. What you will get? That is v square is equals to n square h square by 4 pi square m square r square. Okay, now substitute v square in equation 1. Substitute v square in equation 1. Okay, now in equation 1, let us see here. In equation 1, that means in equation 1, z square by r square, that is equals to m into v square, that is n square h square by 4 pi square m square r square. Okay, see that the similar terms can be cancelled on opposite side. Okay, that is 1 mass of the electron and 1 mass is cancelled. R square cancelled. Then let us take out r we should represent here in this. This is z square by r square, that is equals to m by r. Okay, m by r. This is v square is equals to complete. This entire thing is v square. Okay, entire thing is v square. Now cancelling of r terms. Now radius of the orbit is equals to, let us see, n square h square by 4 pi square m. Okay, ze square. This is the radius of the orbit. The radius of the orbit can be given by this equation. Okay, once again from the beginning. Okay, according to Bohr, the electron is revolving around the nucleus in circular orbit. In the circular orbit, the attraction force between the electron and the nucleus, that is called centripetal force. The nucleus is attracting with this much of force towards the center. The same amount of the repulsive force is acting on the electron to keep away from the nuclear attraction force. That is called centrifugal force. Okay, according to Coulomb's law, for a stationary orbit, so that is the centripetal force is equal to the centrifugal force. Okay, so then say it is equation number 1. Okay, now according to the angular momentum of electron in circular orbit, so that is mvr is equals to nh by 2 pi. So v is equals to nh by 2 pi mr. Okay, done. So squaring this equation, squaring on both sides, what happens? V square is equals to n square h square by 4 pi square m square r square. Okay, done. So v square, put the v square value, putting v square in equation 1. Putting the v square value in equation 1. Okay, in this equation. So that is where. So now z square by r square, that is equals to m by r. Okay, m by r. V square value, v square is the entire value we have to represent. So that is v square n square h square by 4 pi square m square and r square. So cancellation of m and 1m and r square, and now taking out r, radius of the orbit is equals to n square h square by 4 pi square m ze square. So this is radius of the nth orbit. Now this is the derivation is done. Okay, now what is the significance of this equation, where it is useful? Okay, let us see. Okay, up to this is done, clear? The concept is clearly understood. We should remember this. Where, see, let us here only will explain that. So where n is equals to first orbit, because Bohr's theory is strictly applicable to the species which containing one electron, species like hydrogen atom or helium ion or lithium 2+ ion or beryllium 3+ ion. So Bohr's theory is applicable to one electron containing species. So now for which you can use n is equals to 1. So that means I want to calculate radius of the first orbit, and h is equals to Planck's constant value. Let us consider Planck's constant value as 6.625 into 10 to the power minus 28. This is ergs second. Okay, and pi is equals to, we know the value of pi, that is 3.14. that means 22/7. Okay, then m is equals to mass of the electron, that is equals to 9.1 into 10 to the power minus 28. This is 10 to the power minus 27 ergs. Okay, 9.1, it is 10 to the power minus 28 grams. That is mass of the electron. Okay, then Z is equals to the species which containing one electron. Say for example, if it is hydrogen, so hydrogen atomic number of hydrogen is equals to 1. So then the charge on the electron, that is 1.602 into 10 to the power minus 19 coulombs. Substituting all the values, we can calculate the radius of first orbit of hydrogen. Okay, radius of first orbit of hydrogen. Okay, so radius of first orbit of hydrogen atom, that is equals to, so substituting all the values, the main point is ergs and mass of the electron in grams. So therefore that value is 0.529 into 10 to the power minus 8 centimeters. As we know that 1 angstrom unit is equals to 10 to the power minus 8 centimeters. Okay, or 10 to the power minus 10 meters. Okay, then we will get, that is 0.529 angstrom units. Okay, it is in centimeters and it is in angstrom units. Suppose if the Planck's constant value is in, consider 6.625 into 10 to the power minus 34 joule second, and mass of the electron 9.1 into 10 to the power minus 31 kilograms. Okay, 9.1 into 10 to the power minus 31 kilograms. If we consider then the radius of the first orbit as like this, then that is 0.529 angstroms. Instead of that, 10 to the power minus 10 meters. Okay, that is, it is in SI units, it is also in, that is SI unit, that is kilograms. So we get this one, or 0.529 angstroms. Okay, we know that. So this is the way to calculate the radius of the first orbit of hydrogen, that is radius of first orbit of hydrogen. Okay, it is very simple and interesting. Numericals are there in our textbooks. So for all the competitive examinations, the radius numericals are very, very important. Okay, even it is simple also. Now this is radius of the first orbit of hydrogen. Okay, now sir, I want to calculate radius of the second orbit of hydrogen and third orbit of hydrogen, fourth orbit of hydrogen. That means for the convenience sake, to calculate radius of nth orbit of hydrogen. Okay, radius of nth orbit, where in hydrogen atom, radius of nth orbit in hydrogen atom, that is equals to radius of the first orbit, that is 0.529 angstroms into n square into n square. That is one shortcut we can use. Radius of the nth orbit. So you can calculate second orbit. I want to calculate radius of the second orbit. That means 2 square. Okay, 0.529 angstroms into 2 square. Suppose you want to calculate radius of the third orbit. That means 0.529 angstroms into 3 square. That means 9. Okay, for first orbit it is 0.529 1. Okay, into second orbit 2 square means 4. For third orbit 3 square, that is into 9. Okay, right. This is radius of the nth orbit of hydrogen. Okay, and as we know that the Bohr theory is strictly applicable to the species which containing 1 electron species. 1 electron species means, so the radius of nth orbit, radius of nth orbit of species containing 1 electron, that is helium plus, lithium 2 plus, beryllium 3 plus, for them it is equal to 0.529 angstroms into n square by Z. Z is atomic number of that species. Okay, this is another shortcut logical approach to calculate radius of the orbit. Okay, so this is like this. We can use the different formulas to calculate radius of the orbit, nth orbit in the species which containing 1 electron. Okay, now this is radius part. Okay, it is important. So these formulas are important for our numerical purpose. Okay, numerics. So you have to remember 1 angstrom unit is equals to 10 to the power minus 8 centimeters, and it is in meters. Okay, is it the, I think the concept is clearly understood. So the numericals will take in the next session. Okay, now let us take up, so derivation for energy expression, derivation for energy expression. That means Bohr's equation to represent energy, Bohr's equation to represent energy. Okay, next energy equation we have to derive. So how we can derive the energy equation? See, according to Bohr, the energy, that is when electron is revolving, according to Bohr, the electron is revolving around the nucleus in circular orbit. That we know very well. When electron is revolving around the nucleus in circular orbit, okay, when electron is revolving around the nucleus in circular orbit, so with a radius of r, so this is the nucleus, so around the nucleus, so this electron is making circle, that is orbiting, so with a radius r. Okay, so then due to its position, the electron possesses potential energy, and due to its motion, the electron possesses kinetic energy. Okay, so the kinetic energy of the electron, the position and kinetic energy of the electron. Okay, so now the kinetic energy of the electron is kinetic energy of electron. Okay, kinetic energy of electron around the nucleus when it is moving around the nucleus. Okay, kinetic energy of the electron due to its motion, that is equals to kinetic energy of the electron, that can be represented by, so that is we know that half mv square, that is also can be represented as ze square by 2r, ze square by 2r. That is the kinetic energy of the electron revolving in the circular orbit can be represented like this. Similarly, potential energy of electron, potential energy of the electron is represented by, minus ze square by r, That is potential energy of the electron in the circular orbit. Okay, no, next we can say what is the total energy of the electron revolving around the nucleus in the circular path. So that is total energy. Total energy of electron, that is equals to sum of the kinetic energy and potential energy, that is equals to, that is ZE square by 2R minus ZE square by R, that is equals to minus ZE square by 2R, that is the total energy of the electron. Okay, we can say E, total energy you can say represent as E, that is equals to minus ZE square by 2R, where R is the radius of the orbit, don't forget that. Now let us see what is the R. Now just now we derived that is radius of the orbit is equals to n square h square by 4 pi square m ZE square. Okay, that is R equation. Now substitute R in equation, say it is equation in this equation. Okay, substitute R in the above equation, you can write like that. So that is E is equals to energy is equals to, okay, the total energy of the electron in the orbit is equals to minus Z E square by 2 into R value, that is n square h square by, it goes up, so 4 pi square m z E square. Okay, now let us cancel the similar terms. Okay, right, 2 to the 4. So therefore let us write here only total energy of the electron is equals to, total energy of the electron is equals to 2 pi square minus 2 pi square m z square E square into E square e to the power 4 by n square h square by n square h square. So this is the equation to calculate the energy of the electron, minus 2 pi square m z square e to the power 4 by n square h square. Okay, substituting the value of m, z, 1, n and h, energy of the electron in the first orbit of hydrogen, that is equals to minus 13.6 electron volts, 13.6 electron volts, or you can say, if you substitute, as we know that, okay, 1 electron volt is equals to 1.602 into 10 to the power minus 19 joules. So we can expect that is, we can also put in that is mass of the electron in grams and Planck's constant value in ergs. Okay, so then we can get minus 2.18 into 10 to the power minus 11 ergs per atom. Okay, ergs per atom. Okay, or that is equals to minus 2.18 into 10 to the power minus 18 joules. Okay, so that is a different conversions we can take. So that is the basic equation for today's is derive the expression to calculate energy of the electron, that can be calculated by this one. Okay, that is, this is radius we have done, and energy of the electron also can be derived like this. Okay,